Hello and welcome. Today we are going to talk about IPv6 or IPv4 DMVPN tunnel. So here is the topology. We can go through all the commands and all the configuration. So let's understand the topology first. We have hub and spokes. Two spokes are there. Public IP is already configured and we get public IP. So on hub, if you check show run interface ethernet 0/0, we can verify here we have IPv4 address configured, we have IPv6 address already configured, but we are going to send packet using this IP address. So we are going to use IPv4 address. So the scenario sometimes you may have in your network topology when we have IPv6 topology environment in our office or in our home, and we have another branch somewhere located. We want to send IPv6 traffic to IPv6 network or maybe to another branch using IPv4, and this is what we are going to do here. We get public IP from ISP and we are going to send our internal IPv6 traffic on top of IPv4 traffic. So how can we do that? So we need to configure tunnel IPv6 tunnel on top of IPv4. So IPv4 is acting as transport protocol and IPv6 is acting as passenger protocol. So let's configure tunnel on hub. I'm going to configure DMVPN phase 2. So a lot of commands are similar to IPv4 DMVPN phase 2, and we can easily understand that part if you see the video of DMVPN phase 2 configuration. So let's start configuring hub first. I first define interface tunnel ID, IP address, IPv4 address even you can give, or it's not mandatory to give. I'm simply giving the IPv4 address, but if you want you can give, or if you don't want it's not mandatory. No IP redirect command is not mandatory for DMVPN phase 2, but IPMTU sometimes is mandatory because sometimes we can send packet, or sometimes packet may be fragmented and may not be fragmented. So depends on the how many types of technology you include. You may have, you generally we have GRE here, we may have IPsec, then sometimes we need to adjust this MTU value, but here I am defining 1400. I am doing here IP NHSRP map multicast dynamic. So what I am doing here is this multicast traffic is coming, I am going to dynamically map that. IP NHSRP network ID is mandatory, we need to define that. We need to say this as well. The link local address I am giving, this is only for identification purpose. So hub is having FE80::1 link local. I am giving here this internal IP address. So IPv6 address is this. So this is the IP address which I am assigning to tunnel 2001:192:168:1:1. So here is this network 1 here, I will assign 2 here and 3 here, and on this interface we have 200.0.0.1 here, as we have seen this IP. Okay, the next command I gave is IPv6 NHSRP map multicast dynamic, same as it is we give in IPv4. IPv6 NHSRP network ID, same command. Tunnel source we are using Ethernet 00, which is this interface. IPv6 NHSRP tunnel source, tunnel mode GRE multipoint, tunnel key, here is a tunnel key, I am defining tunnel key 1. So hub side we configured DMVPN phase 2 because we have defined tunnel mode GRE multipoint. Go to spoke and configure another spoke. So commands are again similar to IPv4 DMVPN phase 2, tunnel interface 123. I'm defining IPv4 address, not mandatory. IPMTU, mandatory sometimes. IP NHSRP network ID, IPv6 address, link local address I'm assigning. It's not mandatory to assign. This is only for identification. We can easily identify, okay, this is my next hop, and the link local address of the next hop is FE80::1 or 2. IPv6 address I'm defining 2001:192:168:1:2. Then I'm defining here another thing, mapping, and mapping is the most important thing. Here is a typical thing, and we need to always understand this IP always will be the IP address of your hub router, the next hop router. So IPv6 NHSRP map multicast, I'm gonna send packet in unicast format to this 200.0.0.1, which is my hub. The next is 192.168:1/128. Here I am defining this individual address. If I am looking for any traffic and I want to send, how can I map it? So this is my next hub, and this is public IP of the hub. So this is internal private IP, this is public IP. We always need to define that. Network ID is mandatory. The next hop always will be private IP of the hub. Tunnel source Ethernet 00, which is my NBMA interface. Tunnel mode GRE multi-point, this is for phase 2, and tunnel key is 1. Let's go to another router which is green and configure same as it is. Tunnel 123 IP address. So here is the configuration we have. First I configured this IP, this is not mandatory. MTU, network ID, and link local address. It's not mandatory to configure, but it's for an example. This is our internal tunnel IP. This is the mapping toward NBMA address of hub. This is mapping between tunnel private IP to public IP. So this is the private IP address of hub, and this is public address of the hub. Network ID, next hop server, private IP, tunnel IP address of hub, tunnel source, tunnel mode, GRE multipoint, tunnel key. So all the configuration is done here. Let's have a look at now on hub and verify are these tunnels up or something else. So here is the command show IPv6 NHSRP, and we can see that the tunnels we have discovered and registered with these addresses. One is : 2, one is : 3, one is with the link local address, and this is also with link local address. So these are two addresses registered with the link local address along with tunnel IP. Go to red router and verify same as it is. Show IPv6 NHSRP, and here one tunnel between red and hub. So there are two tunnels on hub, and let's verify with the show IPv6 DMVPN. Can we do that? No. So show DMVPN, we can do that. There is no show IPv6 DMVPN. Show DMVPN, and we can see there are two neighbors, one peer, second number peer with NBMA address. This is the NBMA address, our public address of both the spokes, Attribute D says dynamic tunnel, not statically defined. If I go to red and verify with the same command, show DMVPN, and here is one tunnel, and we have statically defined here, but when we want to send traffic between red router to green, we don't have any tunnel currently, but once we initiate the traffic, there should be a tunnel with dynamic attribute D attribute. So we'll try that as well. So let's try first pinging from hub to the next tunnel IP. Ping, this should be one, this should be 192.168.1 the next stop IP2, and we can see that it's working. We can verify and ping green device. Yeah, this is also working. So our tunnel is currently up, and if we want to verify, show IPv6 interface tunnel 123, and we can see that tunnel 123 is up. This is the tunnel IP. This is our global unicast IP, which I can say is the tunnel unicast IP, and tunnel has joined these groups. And when we enable IPv6, these are the common groups generally interface joins. And if I want to verify something, show IPv6, the command I gave is show IPv6 interface tunnel. I can give here show interface tunnel 123 if you want to verify this as well. So encapsulation tunnel, I would verify like this, show interface tunnel 123. Yeah, so tunnel mode should be here. Here tunnel protocol transport multi GRE, so multi-point GRE protocol, the tunnel mode we are using here. Let's initiate traffic between red to green and see that. So currently there is only one tunnel. I'm gonna initiate traffic for 192.168 this device. From red I'm trying 3, and we can see we are able to send the traffic between red to this device. And this time we can see the tunnel, the on-demand tunnel has been created between red and green, which is going to public IP address of green router, and attribute we can see is D. So the configuration is similar to DMVPN phase 2 of IPv4. So it's not difficult to configure IPv6 over IPv4 DMVPN. So let's take a review what we configured. First we configured hub with these commands, show run interface tunnel 123, and see that we have defined these, configured tunnel mode multicast, tunnel mode multi-point GRE. Go to red and verify show run interface tunnel 123. All these commands are making tunnel up, show run interface tunnel 123, and everything is fine. So you can run now any routing protocol, either you can run static routing or dynamic routing, and we can have reachability between our both the sites between red and green using IPv4 as a transport protocol and IPv6 as a passenger protocol. So I hope it has been informative for you. Thank you and bye bye.